Hi everyone, this is question number 4 in our riverboat problem and welcome to the Level Up series. So I hope you have solved all the other 3 questions as well as the theory behind it. Now this question states, and it is an interesting question, that it states that there is a river of width D. So let me just draw the river, and there is a width D of the river which is given to you. Okay. Now it says that the boatman steers the boat always aiming towards a point that is directly opposite to the starting point, and this is the point we need to visualize. So let's say a boat starts at this point initially, and this is the opposite end. So initially what will happen, the boatman is moving in this particular direction because this is the starting point, and it states that it is always steering towards a point that is directly opposite to the starting point. So if this is the starting point, this is the directly opposite point B. So after a certain time, what will happen? River will pull it and it will move to this particular position. So again, it will point towards this, and river is pulling in this direction. So there will be some resultant and so on. So it will move, point towards this, river will pull it, and actually you see that there is a trajectory which is happening, and finally it will merge with this because it is always pointing towards B. So this is how the boat will move. Now to solve this question, how to approach this? So again, it's very important that what we are learning here is either unique way of solving a problem or a unique way of approaching, how to think about approaching this kind of problem. So I don't know whether you have solved or you have studied a line of approach or not. If you have not, I will take a series on that. So clearly, let's say we take this point and we try at some point the man velocity is in this direction, so or the boat velocity is in this direction. So let's say this is velocity of the boat with respect to the river, and this is the river velocity. Okay, and let's say at some point this is making some angle theta with the vertical. Okay, so now you see that this velocity or this line is reducing. Initially this length was some width D, and then it reduced, this length reduced, afterwards this length reduced, and this length is constantly reducing, and finally it will become equal to 0. So clearly we know that this length is decreasing from D to 0. So this length or this distance will reduce from D to 0. So if we actually find out this distance, we'll be able to find certain things. So the first approach will be that velocity along this particular direction is VBR minus VR sine of theta. Okay, because this is angle theta, this is 90 minus theta, so VR sine theta, and this will be equal to minus of dl by dt. Okay, so this will be equal to minus dl by dt. Now if I approach it like this, so what will happen? VBR dt minus VR, which is constant, sine theta dt, and minus is because this length is reducing, and it will be equal to minus of dl, which will go from D to 0. Okay, so now we don't know theta as a function of time, right? We can also use r d theta and those concepts, but I'm actually sparing that concept at this point of time. So we'll just stick to this. So this is the first equation which we have got. Now clearly we know that in x direction, so if we find the velocity along the x direction, that x is 0. So displacement along the x is equal to 0. So the second equation which will come to me is VBR, the horizontal component, VBR sine of theta minus VR, right, is equal to minus dx by dt. I can say velocity along the x-axis is this, and this will give me VBR sine theta dt minus VR dt is equal to minus dx, and this will be from 0 to 0, and therefore from this second equation what I will get is I will get VBR integration of sine theta dt is equal to integration of VR dt, and I will say, let's say it is VR into t. So 0 to t, 0 to t, everywhere we'll put 0 to t because it is moving from 0 to t. So now what will happen is I will get this. So clearly you see this whole expression, which I don't know as a function of time, theta I don't know as a function of time, I can get it from here, and what I will do is I will actually get integration of sine theta dt will be equal to VRT by VBR, and now it becomes very easy peasy because now we'll have to simply substitute it, and from here I will get, if I substitute the whole thing, sine theta dt, I will get VBR into t minus VR into VRT by, so let me just reduce this, VRT by VBR in is equal to d. Okay, so from here I will solve it and I will get the answer as t is equal to d into VBR upon VBR whole square minus VR whole square. So this is what I will get time as in this particular question. So clearly you see the approach was not difficult. The only thing is, I know and I believe in this theory that if you don't know the approach, it means clearly that you have not spent enough time on a problem. So clearly here, I just summarize this. I will try to summarize this question, that what is happening here is how to visualize. And if it is said, just try to draw this diagram. And once you start drawing this diagram, for example, what I did was, initially it was like this, then it moved like this, then it moved like this. So it clearly was indicating something, that this length was decreasing. And from there, as a teacher, I got the idea that, oh, okay, this length is decreasing. So clearly, if I'm able to visualize this length and find some way of finding an equation along this line, then I will be able to solve this question. And actually, this is how I got the first step, right? And this is how you need to also think about the first step, that this line, this length is decreasing with time. And this is called line of approach. So we will study about this line of approach very soon in our following lectures, and just stay tuned to this channel and you will get a lot of problems every day, 1 or 2 problems on physics, which will be mind-blowing, which will actually help you strengthen the concept in a particular area, right? And as we proceed, as the group will increase, we'll try to increase this question to 2 or 3 or 4, and we'll create a separate Telegram group for this physics lovers, right? For all you physics lovers. So if you like the solution, give me a thumbs up. This answer is very simple. It is dVBR by VBR whole square minus VR square. So, and please share it with as many friends as possible if you like the solution, and just subscribe the channel so you can keep coming to this channel again and again. Okay, see you soon with another question.